In this video, I'm going to show you how to perform both a two-sample t-test and a paired test in SAS Studio. So let's start with a two-sample t-test. So remember, with the two-sample t-test, we have two different samples, and we're taking one measurement from each sample or each group to see if a treatment that we are applying to both of the groups is going to make a difference between the two groups. So obviously group 1 is going to get one type of treatment and group 2 is going to get another type of treatment. This is really common in things like clinical trials where we have two groups and one group gets the treatment or the new drug and the other group gets a placebo or no drug. So we really need a data set that kind of looks like this. We need a data set that has one column that has all of the quantitative measurements, and then one column that determines what group the person is in or what group is the reading from. So let's take a look at a data set that will work pretty well with this. So for this, we're going to go ahead and look at our class data set. So let's go to libraries, and we are going to navigate to our class data set. And let's go ahead and maximize our workspace. So here what I want to take a look at to see is if there is a difference in GPA between students who are right-handed and students who are left-handed. So we're going to take a look at that. So that works perfectly because we have a GPA column. If I scroll over here, we'll find our GPA column. So we have a GPA column here, and we also have a column earlier on in the data set that indicates whether they are right or left-handed. So the hand column is dichotomous. They're in group 1 or group 2, and it's really important that that column is dichotomous, and if it's not, if it has multiple different levels or multiple different options, you have to make sure that you filter the data set so you're looking at just two groups. So in this case, we don't have to filter the data set. We did not ask if people were ambidextrous, so we only have left or right-handed people, and GPA is a quantitative column. So that's all we need. All right, so let's go ahead and go back to our task view, and we're going to go to Tasks and Utilities and Tasks. And the two-sample t-test is under the statistics group, and we're going to go to the t-test task. So let's open that up, and let's once again maximize our workspace. So here we're going to change our data set to the class data set. And for the t-test option under roles, make sure we pick two-sample test. This is our two-sample t-test. So here we have to, under analysis variable, select the quantitative column, and then in the groups variable, you select the column that has the group in it, or the dichotomous column. So for analysis variable, we'll click the plus, and we're going to look at GPA. And for the groups variable, we're going to click the plus, and we are going to look at the hand column. All right, so remember, quantitative variable under analysis variable, and categorical or groups variable under the groups variable. Let's go ahead and click into options. Here we select under tails whether it is a one-tailed or a two-tailed test. And if it's a one-tailed test, whether it's an upper one-tailed or a lower one-tailed, depending on what your alternative hypothesis is in your two-sample t-test. In this case, I'm just going to take a look to see if there's a difference between the two groups. Is there an effect, or do we see that whether someone is left-handed or right-handed seems to be different for or it causes a difference in their GPAs. So I'm going to do a two-tailed test, and you don't want to touch the alternative hypothesis here, and you just go ahead and run the task. So once it's done running, we have lots of output on our screen. The first thing I want to do is to make sure that the two groups look nearly normal when we graph them on a histogram. So here is the GPAs for left-handed students, and here are the GPAs for right-handed students graphed in a histogram. And they're somewhat normal. There are some outliers here for the right-handed people way down here, but in general, the data is not super skewed. So a two-sample t-test would be pretty appropriate for this particular data set. All right, now if we want to find the p-value, we're going to find it right here under pooled. You'll notice under pooled, you have a p-value of 0.2708. So in this case, we failed to reject the null hypothesis. And remember, the null hypothesis in a two-sample t-test is that there pretty much is no difference between the two groups. And so in this particular case, we fail to reject the null hypothesis. So we can pretty clearly start assuming here or start figuring that it doesn't look like whether someone is left or right-handed has any effect on their GPA. So this treatment, which is their handedness, doesn't seem to be different between the two groups. Now, there actually is somewhat of a difference, but it's not a large enough difference. Remember, that's the whole point, is that we will expect there to be a different average difference, or sorry, a different average GPA in the two groups, but we want to see, is it statistically significantly different? In this case, it's not. So that is how we would do that for a two-sample t-test, and in this case, a two-tailed two-sample t-test. All right, so that's a two-sample t-test. Let's move over to a paired test now. Now you remember, a paired test, instead of looking at two samples and taking one measurement from each sample, we have one sample, but we have a measurement before a treatment or an intervention, and then after a treatment and intervention. So think back to when you may have taken a course in high school on how to improve your SATs or your ACT scores. If you remember, what you maybe would have done when you took that course is you took a practice SAT before you took the course, and then you went through the course, and then you took a practice SAT after. So it's the same person, it's still you, you're the same group or the same subjects, but you're having a measurement taken of you before an intervention or a treatment and after an intervention or a treatment. So that is the type of data that we need to work with. So we need a data set that has pre-scores and post-scores, or pre-readings and post-readings. So for this particular one, I'm going to point you to a different sample data set. So let's maximize our workspace here, and let's go back to libraries. And for this one, I want you to open up the consumer spending data set under data sets. Let's go ahead and maximize our workspace just temporarily. And so here you notice what I have is 1,200 credit card holders and their spending each month from December through April of the following year. So what I'm interested in this particular case is, do we see a decrease in spending from December to January? We all know that holiday shopping is really expensive, so we spend a lot of money in December, and then what happens? We get that credit card bill at the end of December, and we go, oh my gosh, that bill is so expensive, it's so high, I really need to cut my spending in January. So that's what we think is going to happen to our credit card holders, that we're going to have a significant decrease from December to January. Well, this is a perfect data set for a paired t-test. So let's go ahead and give that a try. We want to test that hypothesis. And remember, the hypothesis of a paired test is that there really is no difference between pre and post, so the pairwise differences are pretty much zero, or at least not statistically significant. And the alternative hypothesis is either there's been a decrease in the difference or there's a positive difference, so either a negative difference or a positive difference. Either one, depending on what type of paired test you're doing, whether it's one-tailed or two-tailed. Okay, so let's go ahead and set up this t-test. So I'm going to go ahead and unmaximize my workspace. We're going to go back into the t-test task, and we're just going to set it up a little bit differently. So in this case, I don't want to work with the class data set now. Now I want to work with consumer spending. So for the t-test option here under roles, we want to change this now to a paired test. Now what's important here is what you put in group 1 and what you put in group 2. I want to go back to the data set just for one moment. Remember, what I'm thinking here is that I will have a negative difference between December to January. So just let's apply some fake numbers here. What I'm saying is if a cardholder spent $1,000 in December, I think they spent less than that in January, right? I think spending decreased. So if I want to show a negative difference, I would have to take my January spending and subtract my December spending, because January will be lower. If I subtract a higher number from a lower number, I should get a negative difference. So in this case, I'm treating January as my post and December is my pre. And the intervention in between is the holidays, is holiday shopping, right? So if I want to show a negative difference, I want to take my post minus my pre. It's usually good practice to always calculate the difference as post minus pre. It's just easy to remember. And then depending on what your null hypothesis is, then you'll be able to decide whether or not that difference should be negative or shown as positive. So in this case, for group 1, I'm going to pick January, and for group 2, I'm going to pick December. So if you're not quite sure how you should calculate this, hang tight, and when you get your output on the screen in a moment, you will see how SAS calculated the difference. So now I'm going to go into options, and here's where I once again select my tailedness of the test, whether it's a two-tailed test, an upper one-tailed, or a lower one-tailed. Remember, this is matching your alternative hypothesis. So in this case, I think spending has decreased, so I think the differences will be negative. So I'm going to pick a lower one-tailed test. Okay. All right, and you'll see here where it says alternative hypothesis that mu1 minus mu2, in other words, mu differences minus mu differences 2 is less than 0, and that's what I think. I think I'm going to have a negative difference. All right, so I'm going to go ahead and run this test. And when you run it, once again, before we look at the output, I want to look at a couple quick things. One, first of all, notice that SAS does state how it calculated the difference. It's taking January and it's minusing or subtracting December, which is exactly what we want. If I scroll down and I look at my histogram, it's graphing the differences here, right? So it's subtracting January minus December, and it's graphing the differences. And you notice in some cases the differences were very high, in some cases the differences were quite negative. So when I go ahead and look now I can take a look at my p-value. So here's my p-value written right here, and you'll notice my p-value is pretty much 0, which means we are going to reject the null hypothesis, which does seem to indicate that there is a negative difference in spending from December to January. In fact, if I look at my mean up here, on average, my difference is negative $163.20. So there is a significant, statistically significant negative difference in spending between January and December. If you were looking to see if there was just any difference at all and you weren't interested in direction, you would change this tails from lower one-tailed in our case to a two-tailed test, and then you would rerun the test, and you would notice once again the p-value is pretty much close to 0 because we've already determined that there is a difference, and in fact it's a pretty statistically significant negative difference between the 2 months of spending. All right, so there you have it. We've gone ahead and performed a 2-sample t-test and a paired test in SAS Studio. Thanks for watching.